My name is Kalhan Barlasa. I'm a research assistant and a PhD student in the electrical engineering department of University of Moratuwa. This is the Smart Grid and Microgrids webinar series. We are conducting this for some time now, and this is organized by our Smart Grid research group. Today's session is on multi-agent systems-based energy management system for microgrids. This our webinar series is mainly about smart grid and microgrids, and also we did some sessions on distribution system automation, and now we are doing sessions on microgrid control actually. In the future, we will be doing sessions on microgrid protection, planning design, and also some modeling. Also, as the last section of our this webinar series, we will be doing some sessions on AI applications in the smart grid. As for today, our today's presenter is Vimukkthi Vithanage. He completed his BSc Engineering degree from University of Moratuwa in the Department of Electrical Engineering, and he has worked as an electrical engineer in the solar power sector in Sri Lanka. He also worked as a visiting instructor and also both in University of Moratuwa as well as in ISL College of Engineering. And in 2020, he completed his master's degree. Currently, he is working as a professional lecturer in electrical engineering in the Sabaragama University of Sri Lanka, Faculty of Technology. Vimukkthi, I will hand over the session to you.
Okay, thank you, Kallan. Thank you, Kallan, for the kind introduction. Let me share the screen. Yes. Okay, good evening, everyone. Before going for the topic, I would like to thank Professor Udayanga Hemapala, who was always behind us from our undergraduate level, guiding through these researches. And for the particular research topic, I would like to especially mention about Professor Anura Vijayapal. He also supported me for this research. And also thank you, Kalhan, for the invitation and for organizing this wonderful webinar series, which is very important for research students who are following research under these subjects. So today our research topic is I'm going to discuss about multi-agent system-based energy management systems for microgrids. So I know throughout this webinar series, there were sessions about microgrids, microgrid controlling, microgrid battery management systems, and also sessions regarding the reinforcement learning and forecasting based microgrid controlling. And there were a lot of sessions which were discussing very important research areas. So this multi-agent system-based control systems also a very important research area, and currently a lot of researchers are going based on this multi-agent system-based controlling for microgrids. There are a lot of active researchers related to each other. So I'll be basically explaining what is the multi-agent concept and how we can use multi-agent concept for the energy management in microgrids, and what is the research path I selected, and how I was able to gain the results throughout my research. So I will be explaining that also, because I thought it will be important for the research students when going through their researches, so they can get some idea about the path I followed. So okay, so to understand the topic properly, So as I mentioned, our topic is multi-agent concept-based energy management systems for microgrids. So to understand the topic, we need to understand these three main terms. First one is microgrid. The second one is what is energy management. And the third one is what is a multi-agent concept. So I know you have a very clear idea about what is a microgrid and how it is operating, and what are the control techniques we are using, and what are the advantages, disadvantages, and everything. I know you have a very clear idea, because now we are going through a sequence of webinar series and also energy management. So I thought of I should start with this multi-agent concept. So right. So to understand the multi-agent concept, we need to have a clear idea about what is an agent. So an agent is, as I mentioned here, an agent is an intelligent entity with autonomous behaviors and learning features. So if I explain it in simple terms, so it's an independent control system which can take decisions by itself and do changes to a particular environment, right? So for example, an agent can be a control in autonomous car, or it can be a trading bot who doing automated tradings in some kind of exchange or something, a financial exchange or something, a bidding bot. Or it can be, for example, now we have AI based supporters, AI assistants like Siri. So it can be also considered as some type of agent. So an agent is an intelligent entity. That's mean it can learn, it can take decisions by itself, and it can act autonomously, right? So that's the main idea of an agent. So if you look at this figure, let me take the right. So if you look at this figure now, in this figure, I'm trying to explain the operation of an agent. Now, if this is the agent and this is the particular environment where the agent is placed, that's mean, let's say, if it is autonomous car, it's if it is an agent which controls a autonomous car, the environment can be considered as the road, right? So the agent is continuously taking inputs from the environment through the sensors. So it measures the distances for the other vehicles, it measures the road conditions, like that. It takes the full idea about the environment through the sensors, and it 100% identify the status of the environment, right? So after that, it considered its previous experience and also the set of instructions we have given, and it take the decisions based on them. So after that, after taking the decision by itself through the actuators, it do the changes for the environment to achieve a particular objective. So that's the basic operation of an agent. So simple thing we need to I understand is it's placed in a particular environment, and through the sensors or some other methods, it completely take the idea about the environment, completely identify the environment. And after that, after taking that idea, following the particular rule set or the model we have provided and the previous experience about the environment, it takes the decisions by itself. It takes the decisions by itself autonomously, and it makes changes to the environment. So that's the main idea of an agent. So it's an intelligent entity and can work autonomously. So when considering an agent, there are four basic characteristics. I have mentioned them here. First one is it's autonomous. I mentioned it. Autonomous means it can take decisions by itself. And the second one is it's social. So this is a very important characteristic. So social means it can communicate in between each other. If there are more than one agents for a particular system, it can communicate in between each other and share information and achieve their objectives. And the third quality is the reactiveness. So I also mentioned that reactive means it can identify the changes in the environment and make actions for them, make particular actions for the environment based on the measurements or parameters it identifies through the environment. And the final one is the proactiveness. So proactiveness means it's a very important characteristic of an agent. Proactive means it can initiate the process. That means it can do the starting actions. So that's possible because it's an intelligent entity. We do not need to give and separate command. It can take the decisions by itself and make the initiate the process. So this is what an agent is. So I think you have some type of understanding now what is an agent and how it actually behaves. Okay. Right. So these are some of the applications in present world where we are using agents. I think sometimes you may have heard about massive multiple agent simulation systems in virtual environments. So this is a tool we are using in film industry and game industry for mass crowd simulations. So agents are used there, and also AI assistants like Alexa and Siri. I mentioned before, trading bots, autonomous vehicles, navigation systems. So there are a lot of applications where we currently use agent-based technologies. And when discussing further about agents, there are many types of agents. We can categorize them based on their quality and performance. First type is simple reflex agents. So this is the most simple type of agents. That's mean basically it just consider the current status of the environment and take actions based on the current status only. So it's the most simple type of agents we can find. And the second type is the model-based agents. And that means it's somewhat advanced than that. It considered the current status and there is a particular model. So it considered both of them and take the actions. And the third one is the goal-based type. So goal-based types means there is a particular objective given to that agent or a particular responsibility given to that agent. So that agent always follows or always take actions based on the upcoming sequence of actions. That's mean it always keep that goal in the final step and take the actions to follow that. And the final one is the learning agents. So learning agents means the agents which can learn from their past experiences and update their performances based on that. So if we consider the simple reflex agents, it's not that much adapted to the changes in the environment, but the learning agents are more adaptive to the changes in the environment. So there are different types, but based on the applications, we can select what type of agents we have to use. Right. Now let's consider the multi-agent systems. Now we have idea about the agents, and now we can look at the multi-agent system. So simple idea is a system which has more than one agent. So that's a simple idea. The system which has multiple agents. So it's a as displayed in this figure. So you can see it's a set of agents, right? So each agent located in a particular environment, and it takes inputs, it sends the inputs from the environment, and each and every agent can make actions. At the same time, these agents can communicate in between each other. So they are located in the particular environment, they can communicate in between each other, and they can do actions. So each of the agents are given predefined goals. That's mean now we are implementing this multi-agent system for a particular applications. So there are objectives we need to achieve, right? So each of the agents are given a particular responsibility or objective. So they are working for that. And we are calling them the local objectives, the objectives given for the particular agent. And if we consider as a multi-agent system, if we consider the whole system, it also can work as an integrated group of agents and achieve the final objective of the whole system. We call it the global objective. So this is what a multi-agent system is. So if we tell it in simple word, it's a group of agents which can act as an integrated team to achieve a particular objective of a system. So that's the simple idea of an multi-agent system. Sorry, I wanted to show you a video here. I think, yes. Give me a second, please. Yes, this is one of the examples for a simple multi-agent system.
Enter the robot the size of a quarter, developed by engineers. Saying about kilobots that individually they're pretty they're designed to be simple. A single kilobot can do maybe 3 things: respond to light, measure distance, sense the presence of other robots. But these have swarm things. They work together. Robots can organize themselves into shapes, sort of like how cells form into an organ or body. Here's how it works. The robots are programmed all at once, as a group, using infrared light. Each robot gets the same set of instructions as the next. With just a few lines of programming, the robots together can act out complex natural.
Right. So it's one of the example where I can simply give you an idea how multi-agent systems working. So there are different agents. They can communicate in between each other, and they can work for a global objective as a group. So it's an integrated group of agents. So when considering about the multi-agent system architecture, when considering about the multi-agent system architecture, now if you look at this figure, now you can see there are separate multiple agents here placed there, and there is a communication network in between them. And this is the environment where the multi-agent system is located. So if you look carefully, you can see for the each agent, there is a particular area like this. For the second one, there's a particular area, and the third one, there's a particular area like that. So that is the area where the agent is given the responsibility of that particular environment. So the agent is, there's authorized area for that agent, which that agent is responsible. If I come up with an example, let's say in autonomous car, which is controlled through a multi-agent system, there is a specialized agent, a particular agent to control the speed of the vehicle. So the speed of the vehicle is the responsible area of that particular agent, right? So like that, in a multi-agent system, for each of the agent, there is a given responsibility, so that agent has the full authority to take decisions for that particular area, right? So the environment can change depending on the application, and the authorized area can be changed. The number of agents can be changed. There can be hundred thousands of agents depending on the application. But the common factor is they can communicate in between each other through a network, and they can work as a group. So that's the common factor. So this is the system architecture of any multi-agent system. This is the basic idea. So when a multi-agent system is operating like this, these characteristics can be obtained. First one is decentralized operation. Now you can see there are agents, but there are no central controller. Each agents take decisions independently. They can make their own decisions. And that means the system is decentralized. There is no central controller or central governor. And the second quality is these multi-agent systems are very extendable. That means we can simply add more agents if the application changes. So very easily we can do modifications or expand or something. So that's the idea. And also asynchronous operation. The time frames do not matter, right? Dynamic flexibility. While working, they can go for their full operation capability. And the continuous operation. So these characteristics can be achieved through a multi-agent system architecture. So what we actually thought was, if we try to design a multi-agent system based energy management system for a microgrid, we try to achieve these qualities, and we try to give these characteristics for the particular energy management system. And we thought it will be more efficient to manage these intermittent renewable energy sources through this multi-agent system architecture. So that was the main idea, and that is what this research all about. Okay, I think you all have a very good idea about the microgrid. So microgrid can be explained as a mini version of a utility grid. So we know what is a utility grid. There are central power generating units, mass power generating units. There is a transmission line, distribution line, transformers, and end users. So that's the simple idea of a utility grid. But a microgrid can be considered as a scaled down version or a mini version of a utility grid. So basically in a microgrid, we are using renewable energy sources like solar power, wind power, and sometimes diesel generators, batteries, energy storage units, like that. So the issue is, or the challenge is, to control these renewable energy sources. That's mean these renewable energy sources, it's very difficult to predict the power generation. It varies with the environment. It's very intermittent, so it's very difficult to manage the power generation and control the power quality inside the microgrid. So it was our first objective to achieve that through introducing a multi-agent based energy management system for a microgrid. So for example, this is the point I mentioned. So if we consider solar photovoltaic system, the generation is, now you can see it's varies really fast. It fluctuates. Even in a sunny day or a cloudy day, it is not reliable that much. It is fluctuating highly, right? So even for a wind power plant, it's very similar. So it's very difficult to predict the output from these renewable energy sources, and that's mean it's very difficult to balance the supply and demand, because our final objective should be to balance the supply and demand. That means we should be able to supply the power requesting from the loads. But with these kind of renewable energy sources, that means solar and wind, with this intermittent generating patterns, it's very difficult. So that's why we need a more efficient and optimized management system to control these sources, distributed energy sources. Right. So this is the basic idea of microgrid. We have it's a mini scale grid. We have AC loads, and we have DC loads and DC generators, PV systems, sometimes storage units, and micro scale hydros. So there can be many sources, and this is the basic arrangement of microgrid. And smart microgrids is something we are talking nowadays. So smart microgrid means a microgrid where they are using IoT based or smart modern communication technologies, smart sensing, smart metering, and those things. So it's much advanced version of microgrids. So what we have proposed is a multi-agent based energy management system for a microgrids. So it's something like this. Now you have a clear idea about what is an agent and what is a multi-agent system. So we are proposing a multi-agent system based energy management system for microgrids. So it's a fully decentralized one. It's a fully decentralized one. If you look at these structures, now this first one is a centralized structure. The second one is a distributed type structure, and the third one is the fully decentralized type structure. So we are proposing something like this, a fully decentralized control system, and which can control the distributed energy sources. At the same time, it should be able to control the demand side also. And also this type of structure will support the modern 3D concept. That's mean now energy sector is moving for this modern 3D concept. That's mean decentralized, decarbonize, and democratize. So we are achieving decentralized, and through this controlling, we are giving more opportunity, or we are getting more power from renewables. That's mean we are supporting the decarbonization, and also with these types of developments, people will be able to gain more income, introducing that's mean they can very easily implement their private microgrids. So it also supports the democratization. So it goes with the 3D concept. And the basic idea is we wanted to implement a highly developed communication network in between agents. So that was the only way to manage these energy sources, because as I mentioned before, if the generation pattern is varying that much fast, so there should be way to communicate information very fast and manage the demand side and resources. So that's the only way which we can manage the supply and demand, or balance the supply demand in a microgrid. So so let's look at what is the approach we took. And when considering about the parallel researches, so this is not an independent research. There are a lot of similar parallel researches ongoing, but for different applications in microgrid. For example, microgrid group coupling, energy management in city areas, microgrids proposed DCC model for microgrids using MAS architecture, power balancing system using MAS, and there are a number of parallel researches going for microgrids. Some are going for the energy management also, but the approaches are totally different. So our approach is somewhat totally different from others. There are pros and cons, so I will explain them. But there are a number of parallel researches are ongoing for the particular area. Right. So this is the basic architecture we proposed for this multi-agent system-based energy management system for a microgrid. So as you can see, now these are the sources and loads which we can find in a general microgrids. We have solar photovoltaics, solar PVs, we have wind turbines, we have energy storage units, we have diesel generators, and we have loads, and it's also connected to the grid, right? So we thought that if we assign, we thought that it will be more efficient to control these loads and sources in the lowest hierarchical level. So that's why we assigned agents for each of the unit. That's mean an agent to control the photovoltaic system, an agent to control the DC generator, an agent to control the wind turbine, like that. For each and every source and load, we assigned agents. So now we know if this is a multi-agent system, and agents are responsible for each of the areas in the particular environment. That's mean the environment is microgrid, and each of the agent is responsible for particular units, right? And agents can communicate in between each other. Now communication network is also there. Now the objective is to make these agents work as integrated group and balance the supply and load. So that's what I thought. So this is the basic architecture we proposed at the start. But there are some, I should mention that there are a number of other approaches for the particular topic. Also, there are a number of other approaches from other researchers, and there are some have gained very good results. But I will go through the approach I took for this research. Right. So after deciding the structure, the next objective is to model the multi-agent system. So it's very important to model the particular system before trying to implement this. So we were selecting, we were going through a lot of simulation tools for these agents. So we had to consider a lot of things. First one was the communication. We should be able to simulate the communications, and what was the programming language uses, and whether we have a graphical user interface to get an idea about how the agents are operating, and the security and the availability of sources, whether the source is open source or not, like that. We had to go through a lot of things when deciding which is the tool we are going to use to model this multi-agent system. So there are a number of tools available to simulate multi-agent systems. For example, I have mentioned here Agent Builder, JADE, CapNet, CBDI, DCAF, like that. There are a number of tools, and the programming language, they are using different programming languages, and some of them are not open sources, but some are open sources. So actually we selected this JADE tool for the simulation. The reason for that is this JADE software is an open source software, and it also complies with FIPA standards, IEEE FIPA standards, Foundation for Intelligent and Physical Agents. And at the same time, it is freely available, and it also comes up with the internally built GUI, graphical user interface. So we can easily see the operation and debug the problems through that GUI. So those were the reasons why we selected JADE for the modeling. Actually, I must mention the most of the other researchers, the majority of other researchers who are going through multi-agent systems also mostly use this JADE platform, Java Agent Development Environment, to simulate the agents. Right. So I will simply demonstrate how to create an agent using JADE. So you can use any Java IDE for that. So there are a number of Java IDEs, Eclipse, NetBeans, JDevelops, like that. So most of them support this JADE. So you can easily these are open sources, and you can very easily download and use them. And JADE also, it's an open source. You can download it from this jade.tilab.com website. So it's freely available. It's just a set of source codes, so you can just download it. And this Xclipse EDI I'm using, it's also can be downloaded from their official website. So I'm going to simply demonstrate you how to create an agent, and it's very simple. You just need to follow very simple steps. So to the Eclipse Network IDE, create a simple Java project. Right. And you can just add the JADE source through Java build path. Just like this, and apply it there. And then create a new class. Let's name it as agent1, right? Right. And after that, we had to take the source code there. After that, you just need to give the configurations. Go to run configurations. Right. So like that, we can very simply create an agent. So as you can see, agent container, main container, now it is ready, right? So I will explain these things. So we can very easily create an agent, and this is the graphical user interface created. So for the particular agent, there is a particular ID. We call it the AID, and there are two default agents created within the main container. So I will explain it, what are the purpose of them. So like that, we can very easily create an agent, and we can easily program them as we need, and they can communicate in between each other. We can add multiple agents for the same project and program them as they need. Now, if I show you the source code where I used for the one of the agents in the my research. Now this is the server agent. So we can call for the inputs or the informations from the other agents as we need, and we can process them, and also we can send the informations to the other agents. So the more important feature of this JADE is it supports the parallel operations. It supports the parallel operations, so it's not that much easy in MATLAB. Otherwise, it will be more easy if we could simulate agents in MATLAB directly. But the problem is MATLAB is not that much. It is not that much easy to run parallel operations when we are running multiple parallel operations. But JADE allows that. We can very easily run agents parallelly, working continuously. So that's an advantage of JADE. And the building an agent is not very difficult. It's very simple in JADE, but we need to run the agents for the particular predefined algorithm. Right. So right. So this is okay. So this is the basic structure of JADE, Java Agent Development Framework. So I showed you when we created the agent in Eclipse, there were two default agents created, DF and AMS. So this DF means Directory Facilitator. Actually, it works as a yellow page service for the particular project. That means it displays all the capabilities of other agents. So other agents can request for a particular service from the relevant agent. So it's something like that. And the AMS means the agent identifier. So this agent is responsible for giving the agent ID for other agents. And also it's responsible for adding or removing agents from the particular multi-agent system. So this is the main container we saw. And this is the agent we created. And these are the defaultly created agents, DF and AMS. So those are this is the basic structure of a multi-agent system modeled in the JADE platform. Right. So this is the proposed system architecture for the multi-agent based controlling. So this is the microgrid architecture we proposed with a simple PV system and wind turbine unit and a storage unit and a 1 kilowatt diesel generator. And we considered two types of loads, critical loads and non-critical loads, because we wanted to show that it's able to manage demand side also. So, and we defined agents for each of the unit, for each of the source and load. And we try to model the system in JADE and do the controlling for the energy management. So these are the considerations we need to pay our attentions when applying multi-agent system concepts for the microgrids. So first one is size of the microgrids and technologies to be used. We need to understand what amount of agents we need to implement and how the hierarchical level should be arranged when organizing the particular multi-agent system for the microgrid. And type of resources integrated and their positions, energy dispatching algorithms, and communication protocols which we are going to use, and voltage current controlling mechanism. So there are a lot of considerations we need to pay our attention when applying multi-agent concept for a microgrid. So considering them, we defined a particular set of agents for each of the units for the proposed multi-agent system. So we developed 7 agents, PVA, WTA, GTA, ESS, CL1, NCL2, and SA. So like that, we defined 7 agents and gave the responsibility of each of the unit, each of the source and the load for the particular agent, and try to control them. So when creating each of these agent, each agent got a particular ID, so it can communicate to other agent through that ID. So that was very important, and they also has the capability to work parallelly. That's mean it's not one operation after one operation. Each agent can work parallelly if they want. So there is no barriers. Each agent is independent from the other agent, So that kind of simulation can be done through JADE. Right. So this is the basic arrangement of agents. So as I mentioned, these are the agents and they are connected through a communication network. Each and every agent is connected to each other, right? And there are three types of agent. The server agent, so it has the responsibility of the main grid circuit breaker and all the other measurements from the utility grid. And there are load agents which are responsible for critical loads and non-critical loads. And there are DES agents which are responsible for power sources like PV, wind, and diesel generator. And so this is the operation structure of agents within the microgrid. So this is the same thing I mentioned. This is the physical grid, and in between them, the set of agents are operating, and they are linked through a communication network. So it's the multi-agent concept. The same concept we have directly applied to the microgrid. There is no difference to that concept. Same multi-agent system I explained at the beginning is directly applied to the microgrid. So that's the structure we proposed. So these were the objectives we wanted to achieve through implementing this energy management system. The first one is we need to minimize the we wanted to maximize the customer's power availability. That's mean we want to balance the load demand and supply as much as possible for a longer duration of time. That's mean the availability of power is increased. And we also, the second objective is we wanted to minimize the economic factors. Like now we have a diesel generator in our proposed system. We need to consider fuel cost, operation cost, and those things. We had to minimize the economic factors. And we had to considering minimizing the environmental impact. That's mean the most important one is we always wanted to use the renewable sources as much as possible. That means we had two renewable sources in the proposed microgrids, solar and wind turbine. So we wanted to optimize the we wanted to make the usage of those two sources as much as possible than other sources. And the next objective was we wanted to minimize the energy purchased from the outside of the microgrid. That's mean the utility grid. We wanted to minimize that. So when we are minimizing that this our microgrids is becoming more and more independent from the utility. So those were the objectives we wanted to achieve. Through the proposed microgrid. Right. So this is the control algorithm we proposed to control the microgrids, and this is how the agents are operating. This is the algorithm which the agents are following when controlling the microgrids, those sources and loads. So at the start, the survey agent takes inputs from all the loads and source agents. It takes all the power inputs and demand inputs, and then it considers with the renewable energy left. That's mean if the load total load request is less than the total renewable energy generation, it take the decision. So that decision is taken by the survey agent. And after that, if it is years, it seeks for extra power from battery or the utility grid. If there is extra power, it charges the battery considering the SOC. And if there are more power, it sells the power to the utility grid. And if the generation is lower than the demand load request, it mainly check to take the requested power from the grid. And if it is not enough, it checked for the diesel generator agent. And like that, it follows a particular algorithm we have given to follow. So this algorithm, it's something we gave. So depending on the status of the microgrid, we can change the algorithm as we need. So it's as this is a multi-agent system, the making the algorithm changing and making those changes is not that much complex things, because it's very flexible. We can very easily add or remove agents. We can very easily change the commands given or the controlling of the particular agent. So so those were the advantages when applying this particular algorithm for the controlling. Right. So so basically this part is which the path I followed actually. This is the way I followed. I tried to obtain the results. So basically I considered 4 cases. These are the 4 cases which can happen. The first one is the renewable power generation of the microgrid can be larger than the total demand. The second one is renewable power generation can be lesser than the total demand, and grid is available. And renewable power generation is lesser than the total demand and grid is not available but DG available. And the fourth one is renewable power generation is lesser than total demand and grid is not available and the DG is not available. So those are the 4 scenarios that can happen. So based on that, I took the results for this particular algorithm I proposed. So right. And the next objective was to implement the communication in between agents. So through the JADE platform, they are facilitating us to implement the communication network in between agents. So as you can see in this GUI screenshot, you can see that we can easily send commands to other agents. We can request proposals from other agents. We can confirm the information from other agents. Like that, we can send different types of communication information in between agents. So JADE facilitates that. So it facilitates to implement modular multi-agent system properly. So we have to use a particular agent communication language, ACL. There are particular codes, source codes for that. We have to use them, and it can be very easily implemented. And but the important thing is the communication is done through the agent ID, the particular agent ID. So the communication is done through the particular agent ID. So that's the code where other agent can identify the particular agent. And most importantly, this communication, this also supports the standards of FIPA, Foundations of Intelligent and Physical Agents by IEEE. Okay, right. So if you look at why this multi-agent system improves the communication efficiency, now if you look at this particular path, now if the renewable power generated is larger than the power request from the loads, lesser than the power request of the loads, we need extra power. And if the DJ status is not, if the grid is also not available and the DJ status is not also no, we have to disconnect the non-critical loads. So that's the algorithm I gave them. So if you look at the communication pattern, if in a centralized approach and in a multi-agent system-based approach, so in a multi-agent system-based approach, the server agent can directly communicate to DGA and it can directly communicate to NCLA, a non-critical load agent. So it can directly give the request to remove you from, turn off the non-critical load agent like this. Just have to follow this pattern. But in a centralized approach, the DG agent, the DC generator have to inform the controller. It has to request first and then inform. And again, the controller has to send a command to the critical load to turn off. So it's very clear that as the agents can communicate in between each other, this communication has become much more efficient. So it's one of the main advantages which we can achieve through a multi-agent system-based energy management system, because this communication network supports it well. Right. And also it improves the reliability and communication. Now, in a centralized approach, if a communication link is destroyed, or if the communication link is not working due to a particular reason, the total communication fails in between those two units. But in a multi-agent system-based approach, in such situation, the server agent or any other agent can communicate through the other agent for that, through any other agent for that particular agent. So the communication reliability also increases. So I have showed it here. The communication reliability also improved through a multi-agent system-based approach. Right. So so hereafter I have just included the method I used. So I have just given a particular data sets for each of agent for the particular source, and I have simulated it within the JADE platform and got the results. So I am just showing you the results. I'm not going to explain them point by form. So for each of the cases, we have successfully controlled the microgrid and balance the supply and demand. So as you can see, for each of the cases, the agents are reading the inputs from the sources and loads, and also according to following the algorithm, it gives the command to the particular agents, and agents take the decisions, and it balances the supply and load. So for all the 4 cases, I have simulated and showed that it can be balanced properly. Right. So finally, we can come to these conclusions regarding proposed multi-agent system-based architecture for energy management systems in microgrid. So as it is a decentralized architecture, it has a higher communication efficiency compared to centralized microgrid control architecture. And the second conclusion is the proposed multi-agent system-based concepts can be used to control the operations of microgrid with multiple renewable DERs. So there is no limitations. There can be even hundreds of sources. We can assign different agents and control them. There are no limitations because these multi-agent systems are very flexible and expandable, right? And the third one is these agents can be developed as plug and play modules. So it's a very important factor because a microgrid can be very easily modified or maintained, because these agents can be developed as small plug and play modules. So it's also a very good advantage. So that makes this multi-agent concept based energy management systems more successful compared to the other methods. Okay, I'm going to wind up the session from this point. So I'm welcome. If you have any questions, I'm very happy to answer you. Thank you.